Okay, so today's video is we're going to kind of sum up what we've learned about designing experiments and say, just sum up, can we show causation and can we make inference to a wider population from our experiments? Oops, sorry. So, what kind of inference can we make from either a study or an experiment we did? Well, when we design an experiment and we randomly assign treatments to the individuals, we can show cause and effect. But we can't really make inference to the larger population because people were not randomly assigned. I'm sorry, people were randomly assigned treatments, but they weren't randomly selected from the larger population. So we can show cause and effect, but only in the group of people we were studying. We can't show cause and effect for the wider population. On the other hand, in an observational study, people were not randomly assigned to treatment groups. So we cannot show causality, but because they were randomly selected from the larger population, we can make inferences about the whole population. So let's try and sum that up with this chart, which you may want to put in your notes. First, we got two questions. Were individuals randomly selected from the population? And then once they were selected, were they randomly assigned to treatment groups? And the worst ones are people who are not randomly selected and then not assigned treatments. We can make no inference except for about that group. No cause and effect, nothing we can ascribe to the larger population. This is why you shouldn't trust any internet polls. In a perfect world, well, actually probably not a perfect world, from a perfect statistical standpoint, if we could randomly select people from the population and randomly select people from, then randomly assign them treatments, just grab people off the street, wham, and then randomly throw them into groups, we could then make not only cause and effects, but also inference about the larger population. However, the ethics on that are just awful. You can't just randomly assign people off the street and then do medical trials on them or psychological experiments or anything like that. So that's the tough. So generally we're doing a balancing act between these two on the corners. In an experiment where people volunteer, so they were not randomly selected, but they were randomly assigned treatments, then we can show cause and effect. And in a large study about the population, they are randomly selected. They are randomly selected, but they are not randomly assigned, and so we can make inference about the population, but not cause and effect. A well-designed experiment can generally show causation, but not always. And one of the things that can be a problem is a lack of realism. Is the experiment can't be too simplified, or otherwise it's not realistic. Also, in a lot of cases, we just can't do an experiment. And we'll talk about some ethical ways where we cannot even do an experiment. We'll talk about this lack of realism in a second. It has to do with the third tail light in cars and how they did an experiment and it didn't really make that big a difference, despite what the experiment said. But the realism, the ethical is, could you do an experiment that asked you, does texting while driving increase the risk of accidents? Are we ethically going to go out and randomly assign some people to text to see if they get in a car accident? I mean, that's why we have crash test dummies. And we could do something on simulators, but is the simulator an accurate representation? There are a lot of studies, and this is really fascinating, we'll talk about this more in class, that going to church, people who go to church live longer, but that's a study. There's no cause and effect there. But can you actually do an experiment where you force people to go to church? How about just does smoking cause lung cancer? There was clearly no experiment done there. We didn't randomly select people and make some people smoke for 30 years and some people not smoke for 30 years. So in these cases, how do we establish lung cancer? And it's sometimes possible to build a strong case for causation in the absence of experiments by considering data from observational studies. So how do we do that? Well, if we can't do an experiment, you can make a case for causation if the association is very strong, the association is consistent, larger values of the explanatory variable are associated with stronger responses. For our smoking, people who smoked more had a higher cancer rates. Cause precedes effect in time. And basically, is it plausible? Is it plausible? This is a basic data ethics. Any planned studies, like if you're going to publish when you become a professor or a scientist, you need to have an institutional review board look over to make sure you're not screwing with your subjects. An individual whose subjects, people have to have informed consent. You can't just throw them into the deep end of the pool. They have to know what's being done to it. And data must be kept confidential. You're not going to leak information about individuals. You're only going to share summaries of groups. And that's basic data ethics. This is not on the AP exam, but it's just, we're teaching, we're trying to make better people, so it's important stuff. That's, Smartboard's freaking out here. That's it for today. So I will see you in class tomorrow or the next